Good afternoon, ladies and gentlemen, and welcome to the CSIR's virtual webinar this afternoon, where we launch our Science, Technology and Innovation for a Circular Economy project. My name is Linda Godfrey. I'm a principal scientist at the CSIR and project manager for this particular project. As introduction, what is the purpose of today's virtual webinar? First of all, it's to introduce you, our stakeholders, to the CSIR's cross-sectoral project on the circular economy. Secondly, to provide context on how the circular economy is being interpreted by the CSIR based on local and international learning. Thirdly, to share early insights on circular economy opportunities across various sectors of the South African economy. And lastly, to provide an overview of the next steps of this project, including 3 more detailed sector studies that we'll expand on later this afternoon. So why the need for the circular economy project? Well, firstly, transitioning to a circular economy has been recognized by the South African government as a new source of growth for South Africa. One of the things that will be clear across the various presentations this afternoon is that when we're talking circular economy, we're not talking about waste management. We're talking about sustainable resource management. It's about managing South Africa's future development risks by understanding the availability of resources, the demand for resources, and keeping these resources circulating productively within the economy. In this context, very often we get asked the question, well, what does the circular economy then mean for a relatively resource-rich country like South Africa? Or does the circular economy have relevance in a developing country context such as South Africa? In response to these questions and more, the CSIR is undertaking this cross-sectoral project aimed at better understanding these questions through the lens of science, technology, and innovation. When I speak of a multi-sectoral or cross-sectoral project, we've selected these particular sectors of the economy to focus our initial studies on. So what does the circular economy mean within the context of mining, within agriculture, manufacturing, human settlement, our cities and towns, mobility, and in terms of our cross-cutting economic infrastructure issues in terms of energy and water? I mentioned we'll touch on some of the initial ideas around opportunities within these sectors, some of them listed over here. But ultimately, this project is around unlocking opportunities for South Africa in line with the objectives expressed by government. It's around unlocking new business opportunities and with that opportunities for job creation. It's around decoupling South Africa's growth from resource consumption. It's around improved resource security to support socio-economic development, improving our business efficiency and competitiveness within the local and global landscape. It's around creating thriving, livable, resilient cities, and ultimately reducing the environmental impacts of our economic activities. I mentioned that 3 studies will be taken forward in terms of more detailed work, and the 3 that have been selected for this year is around mining, agriculture, and manufacturing as the foundation for our future research going forward. Our program for this afternoon, we have 8 short 10-minute presentations. So following this welcome and introduction from myself, I will pass over to my colleague Anton Naaman, who will take us through in terms of setting the scene for an overview of the circular economy, and then to each of our various CSIR presenters that will take us through those 7 sectors of mining, agriculture, manufacturing, human settlements, mobility, energy, and water. And finally, just to wrap up in terms of some concluding thoughts of what we see emerging across these sectors, the next steps, and the closure. With that, I'd like to again welcome you to the webinar this afternoon. We look forward to the presentations from our various speakers. And with that, I'd like to pass over to our first speaker this afternoon, Anton Naaman from CSIR Smart Places. Thank you.
Thank you, Linda. Good afternoon, everybody. In this presentation, I'll be providing a high-level overview of what the circular economy is and what it means in the South African context. The intention is to set the stage for the presentations to follow, which will share some initial insights on circular economy opportunities that have been identified to date within the 7 sectors highlighted by Professor Godfrey. South Africa's economy is plagued by stagnant GDP growth, significant unemployment, and persistent poverty and inequality. The COVID-19 pandemic has led to a further deepening of the economic crisis and highlights the urgency for a new development model to drive economic recovery. As a developing country rich in natural resources, South Africa is characterized by an extractive-based economy with large throughputs of resources, much of which ends up as waste, and limited productive returns of resources into the economy. A recent material flow analysis conducted by the University of Cape Town found that the socio-economic cycling rate, which refers to recycled and reused materials as a proportion of domestically processed materials, is only around 2%. A large proportion of the domestically extracted resources are exported for further beneficiation offshore, while there is limited use of resources for building up local stocks of infrastructure, such as building, roads, and rail. This reliance on raw material extraction and exports puts our future development prospects at risk in terms of overexploitation and depletion of resources, and predicted declines in demand for our raw material exports as our trading partners transition towards more circular economy models. Furthermore, while this model has led to economic growth in the past, the gains and prosperity have not been shared equally among the population, further entrenching social inequality. This raises the question as to whether South Africa is using its resources in the best interests of its people and of its development priorities. The need to build back better following the pandemic provides an opportunity to rethink how we are using and managing our resources. Could using our resources in a more efficient and productive way, in which they are retained in the economy for as long as possible, and with a greater emphasis on local value adding and stock building, help to unlock development and employment opportunities? The prevailing economic development paradigm, both locally and globally, can be described as a linear take-make-waste or take-make-dispose economic model. Resources are extracted from the natural environment and used to make products, which are often used for only a short period of time before being discarded back into the environment. Throughout this process, vast amounts of material and energy are used, while significant emissions and waste are generated. The linear economic model is incredibly wasteful, inefficient, and costly. In addition to significant losses in economic value in the form of wasted raw materials and energy, underutilized assets, and disposal costs, the linear model has contributed significantly to natural resource depletion, degradation of land and soils, biodiversity loss, air and water pollution, waste, and climate change. It is becoming increasingly clear that the linear economic model is no longer sustainable and presents a risk to South Africa's future growth. The circular economy is recognized globally as an opportunity to reframe economic development and unlock new opportunities for growth and employment, while achieving global commitments relating to climate change and sustainable development, and reducing the negative impacts associated with both resource extraction and waste. In contrast to the linear economic model, a circular economy entails keeping materials and products in circulation for as long as possible through practices such as reuse of products, sharing of underused assets, repairing, recycling, and remanufacturing. The circular economy has often been narrowly interpreted in South Africa as a waste management issue. However, while recycling has an important role to play, the circular economy is a far broader concept. It is about rethinking the way that resources are used and products are designed to enable more sustainable resource management, keep products and materials in use for as long as possible, and avoid pollution and waste from being generated in the first place. In other words, it requires interventions across the entire product life cycle. The first prize is to rethink and reduce and redesign so as to avoid waste from being created in the first place. This is followed by reusing, repairing, and remanufacturing, and only then recycling. Keeping the loops as small as possible is preferred to avoid losses of energy and materials from the system. Finally, when it is no longer possible to maintain materials within the economy, the last resort is to recover energy. The circular economy therefore challenges us to change the way we think about product design and product ownership, with a greater emphasis on product sharing, renting, repair, refurbishment, upgrading, recycling, and reuse. It calls for a complete paradigm shift, creating opportunities for entirely new business models based on resource sharing, product as service, and access over ownership, facilitated through advances in digital technology. The circular economy is based on 3 principles. Firstly, designing out waste and pollution. Second, closing resource loops so as to keep products and materials in use. And thirdly, regenerating natural systems. As we'll see in the presentations to follow, in the more detailed sectoral studies that are being conducted as part of this project, opportunities are being identified aligned with each of these 3 principles. The circular economy is a systems concept that cuts across all economic sectors. To understand the opportunity that it provides for South Africa, it is necessary to adopt both a sectoral focus and a broad systems approach. In other words, there is a need to identify specific opportunities within key sectors of the South African economy, while also piecing these together into a systems view of the collective opportunity. The transition to a circular economy must also be driven by evidence and supported through innovation. The CSIR is well positioned to inform the national circular economy discourse and to identify circular economy opportunities for South Africa. In the South African context, the greatest opportunities are likely to lie in resource-intensive sectors such as mining, agriculture, and manufacturing, and in those that directly affect human well-being, such as human settlements and mobility. In addition, water and energy are 2 cross-cutting thematic areas which represent key resources and infrastructure for all economic activity in South Africa, and which are currently facing significant constraints in being able to meet increasing demands. The sectoral studies being undertaken as part of this project are aimed at identifying and unlocking specific circular economy opportunities within each of these sectors. In conclusion, South Africa stands on the threshold of profound choices regarding its future development path. In following the global trend for green and inclusive development to be the cornerstone of a post-COVID economic recovery, the President has called for a recovery that is transformative, inclusive, digital, green, and sustainable. A circular economy transition is core to the South African development pathway, with the President affirming that we cannot afford to be out of step with international moves towards green growth and green development. While the circular economy is gaining traction internationally, increased circularity among our trade partners in the EU and China will inevitably have consequences for extractive-based economies such as South Africa. Implementing a circular economy domestically provides opportunities for safeguarding our economy against future resource constraints and volatility in international markets, while unlocking the socio-economic benefits associated with economic growth. It is therefore about managing risks to economic development and unlocking new opportunities for growth and job creation. According to the Department of Science and Innovation's Science, Technology and Innovation White Paper, a transition to a greener economy, of which circular economy is a part, will address the reduction in greenhouse gas emissions, create new markets to assist in the transition to jobs of the future, and keep South African relevant to our trading partners who have already started implementing circular economy policies. South Africa has to be prepared for this new economic paradigm. The CSIR is well positioned to inform South Africa's choices in transitioning to a more circular economy. As we'll see in the presentations to follow, specific opportunities in each sector are currently being identified and unpacked through a series of ongoing studies. Thank you very much. I'll now hand over to my colleague Sumaya Khan, who will kick off with the first of the 7 sectoral presentations.
Good afternoon to all. My name is Sumaya Khan. I am a senior researcher at the CSIR mining cluster. This presentation aims to place the South African mining sector in the context of transition to a circular economy. So what does the circular economy mean for the mining sector? And how could mining companies position themselves to take advantage of the opportunities this model may present? We will firstly begin with a problem statement, then proceed to outlining possible circular economy opportunities for the mining sector based on literature reviews. So as we know, the mining sector is resource intensive, both in provision and the consumption of resources. However, the contribution of the sector to the country's development has been gradually declining over the years due to various factors, such as, firstly, increasing operating costs, complex ore bodies, declining productivity and ore grades, as well as health and safety, social and environmental challenges. Now, if we look at the circular economy model, it is positioned as a framework for economic, social, and environmental prosperity. However, this has not always been the case for the mining sector. The circular economy has traditionally been seen as a threat to the mining sector, and quite reasonably so. The perception is that the reuse and recycling of secondary resources or waste will be favored over primary resource extraction and hence impacting the demand for mining. Also, early concepts of the circular economy placed mining outside of the circular economy loop, as shown on the figure on the left. However, this has changed recently from studies that have shown that the circular economy has a lot to offer the mining sector through sustainable resource use. And this is depicted on the figure on the right. In keeping with the three circular economy principles of designing out waste, keeping materials in use, and regenerating natural systems, we have provided some of the possible opportunities under each of these principles. So firstly, designing out waste and pollution. The first opportunity highlighted is the increased precision and efficiency in ore extraction. New and emerging technologies are currently being explored for reduced energy and water usage, less capital intensity, and less waste production. Efficient extraction of ore may extend the life of mine and increase the range of mineral recovery. This could potentially reduce the need to open new greenfield mines, thereby minimizing environmental footprint and providing diversified opportunities for economic return. Examples of these initiatives are coarse particle recovery, bulk sorting, ultra-fine recovery, and in situ mining. The second point on water recovery and recycling speaks to the need to reduce dependence on fresh water in mining operations. Possible technological innovation in this field includes dry processing, evaporation management, novel leaching, and dry stacking. These initiatives could potentially eliminate the need for wet tailing storage facilities and instead create stable, dry, and sustainable land. And the last point under the principle of designing out waste and pollution is the substitution of raw materials. Substitution could potentially minimize the overall production of waste, reduce health and environmental impacts, and reduce carbon emissions from excessive mining operations. An example of substitution of raw materials is the use of thiosulfate leaching as an alternative to cyanide in gold processing. For the second principle, keeping products and materials in use, we have a few potential opportunities, some of which are already being adopted by mining companies in South Africa. The most common one being recycling and repurposing of waste. An example of this is using waste rock as backfill in open pit mines or for road construction, or making bricks from clay-rich tailings. Then there's secondary smelting of electronic scrap to recover valuable metals such as gold, silver, copper, and palladium. And another consideration is the reuse of fly ash. So fly ash is a typical byproduct of coal mining, and this fly ash could be used to produce geopolymers. And this is an environmentally friendly option that could be used instead of cement in construction. Remining of tailings is another initiative that has the potential to revive economic opportunities for mining companies. Then we have zero waste landfill strategies. And already we have companies such as Kumba Iron Ore that have implemented these strategies that contributes to closing the loop and keeping materials in use. And last but not least, the recovery of potable water. Many coal mining companies in South Africa already use reverse osmosis technology to treat acid mine drainage. This option of recovering potable water can assist in mitigating the growing stress on South Africa's water resources and also creates immediate opportunities for mines to transition to a circular economy. Then moving on to the third principle, regeneration of natural systems. This principle entails more of the longer-term opportunities, whereas the opportunities discussed under the first two principles focused on the lower-hanging fruit. So the impact of coal-powered electricity remains a crucial issue that needs to be addressed for the country to achieve its low-carbon goals. The transition to renewable energy is critical to a circular economy transition, so we may therefore consider integrating renewable energy to power mining operations for haulage fleets, machinery, equipment, etc. And in a brief example, Goldfields Western Area Mine plans to move towards 20% of solar-powered operations by 2022, and it will not be surprising if other companies also follow suit. Okay, so the production of green hydrogen, which is currently a hot topic, has huge potential for South Africa. Green hydrogen initiatives may allude to the adoption of fuel cell technologies in the country, and fuel cells are used to power electric vehicles. Consequently, the demand for platinum group metals or PGMs may increase, as platinum is typically used as a catalyst in fuel cells. And mining companies such as Anglo American and Impala Platinum have already adopted the use of fuel cell electric vehicles at South African mining operations. And furthermore, recently Anglo American announced that they are undertaking a feasibility study to develop a hydrogen valley in collaboration with the Department of Science and Innovation, as well as other energy and services companies. So that brings us to the end of the opportunities for the mining sector in the circular economy. And to conclude, the key points based on this concept note is that, firstly, many mining companies already adopt circular economy principles, however, not at a scale large enough to make a substantial impact on the country. However, the fact that they have implemented some of these principles implies that there is definitely potential to scale their application to achieve a more meaningful impact. Secondly, the circular economy provides us with a model to address some of the current challenges facing the mining industry, including the national objectives of a just transition to a low carbon economy, reducing operating costs, improving efficiencies, and meeting investor requirements for access to capital. And finally, if strategically addressed, the circular economy should not be considered a threat, but rather a model with potential to unlock new opportunities for the mining sector. These opportunities include jobs, alternate business models, low carbon emissions, and reduced environmental footprint. Thank you.
Good afternoon, colleagues. My presentation is on supporting food security and economic development through circular agriculture. We're presenting it with a team of Greg Gordon, Chanel Skuman, Bridget Brown, Boyce Pile, and Linda Godfrey. The problem statement here is interesting because the population is growing very fast and has resulted to increased food demand. Humanity really has a waste problem. Globally, 931 million tons of food waste was generated in 2019, 61% from household, 26% from food services, and 13% from retail. This is equivalent to around 17% of global food production. Food losses and waste in South Africa are estimated to be in the order of around 10.3 million tons in 2021, which is equivalent to around 34% of local production, and in rand value, 61.5 billion rand, which is almost 2.1% of national GDP. I'm raising this just to show the concern of how we waste food in this country. The other problem again is on climate change. And then precipitation of changes in precipitation and temperature patterns has resulted to floods, droughts, new pests and diseases, and different fertilizer regimes. The third one also is on monocropping. We used to do mixed cropping, but now we're doing monocropping, and it has resulted to losses in soil productivity and resultant soil degradation. Now, the three circular economy areas in agriculture are mainly design out waste and pollution. And designing out waste requires to build the principles using resources efficiently to minimize waste. And I'll start with around precision agriculture, which provides enhanced control over inputs like energy, water, fertilizers, and agrochemicals by delivering the right amount at the right time and at the right place. We also have agroprocessing, which results to, instead of wasting your food, you use it now, you can convert it a value added to produce nutritious foods again. And also this, there are many examples in this area, especially in the orange flesh sweet potato area, which we are working. Instead of throwing it, we use it to produce purees and different food products. Another good example, which I want to cite in the precision agriculture area, is Fruitlock, which is by the Western Cape Department of Agriculture. They are offering a state-of-the-art information technology that helps deciduous fruit farmers and grape farmers to be water efficient and climate smart using information from spatial data derived from remote sensing, which provides semi-real-time information on crop growth, evapotranspiration deficits, and nitrogen loss status for the irrigation blocks. What's happening here is that you have fertilizers applied at the right time, you have irrigation, the right quantity of irrigation water applied to your crop. This really saves cost to the farmer, and it generates the farmer benefits at the end from such practices. Now let's go to keep products and materials in use. This involves recycling all nutrients and organic matter materials back to the soil. It preserves the nutrient and carbon levels within the soil and enables farmers to reduce or eliminate external inputs. There is an example which we are doing currently with the United Nations Development Program in KwaZulu-Natal. We realized that we did a data checked on what is being wasted at the markets and realized that almost 350 to 400 metric tons of waste is per month in this market. So we designed an experiment for this particular project, and the experiment is mainly to produce biogas and also biocompost for communities in Kwamashu and Unkomas area. And for the biogas, it's mainly to produce using digesters to produce biogas that can be served around 5 homes. And for the compost, we are using that for gardens in the area. So a home can use a bucket, as you will see in the next slide, which I'm going to show, and apply in the garden for home consumption of their vegetables. And what did we do here? We collected the waste from the Durban Fresh Fruit Market, threshed it, and used what we call effective microorganism to ferment the product. We kept them in a bucket, as you can see in the diagram below, in buckets in an anaerobic condition for around 6 weeks. And then after that, we tried different combinations. In KZN, we have also a problem with a plant called syringa. It's an invasive species, and also another one called Spanish reed. So we blended that into different mixes, 90%, 70%, 50%, and 30%, and full food waste. If you use the food waste alone, you have a lot of water content. So if you mix it, you have a better compost composition. And this is, as you can see from the next slide, the entrepreneur is applying the food waste in a garden. We did a randomized complete block design, and on the picture on the right is how she's applying, looking at the plants, she's admiring her plants. We looked also in the communities in Kwamashu and Nkumas and said, what are these people growing commonly in their area? Because you don't want to produce something, plant something that they don't use. So we try to mimic what is already existing in this area, and we realized that they're growing lots of tomatoes, chili peppers, green peppers, spinach, and cabbage. And that's how we did this trial. We started the trial on the 23rd of September, 2021. And if you could look at the pictures down, I am in Durban today. Today is the 17th of November, and these are pictures which I took at the farms in look at the tomatoes and look at the spinach, how fresh they are. And also we're training the entrepreneur on how to use this technology. The last and third one is the regenerate natural resources. I'll give an example in Kenya. Emma Naluma divided her farm into 4 distinct zones. The first zone was for pig production, and she used the waste to grow insect larvae, which she used the insect larvae to feed chickens and fish feed. And the waste also was used for the growing her bananas, which in Uganda, we have the matoke banana, which is a local staple. And zone 2, she used it for cattle, to raise cattle. Waste is directed to using the same technology which we showed you above for cooking gas, and also for her matoke banana as a compost. And then the zone 3, she used it for aquaponics system to grow tilapia and tomatoes. So the waste from the tilapia is used for the tomato cultivation. And then zone 4, she used it for hydroponic system that produced fodder for her livestock in only 6 weeks. That's very short. Emma benefits from multiple revenue streams, as well as significant reduction in feed, fertilizer, and energy costs. She also has nutritious food which she can get from her backyard, from the project, that the small plot that she has. I think what is important here is the attributes of this, which is soil health, good nutrition, rich biodiversity, carbon capture, improving ecosystem, creating jobs, and better treatment of people. Now, this tells us that we need to come back to our roots using innovation to support regenerative approaches. To conclude, circularity in agriculture has to be reachable, and it has to be tangible. It needs to be a thing that people will embrace because they can afford it and because they see its value. Circular agriculture offers multifaceted wins for people and planet by improving food security, addressing climate change, reducing pressures on land and water, saving costs, and avoiding waste, biodiversity, and waste management system, creating new industries and jobs, and living a healthy life in nutritious food and having nutritious food, like I showed what Emma is gaining in Uganda. Now, lastly, there are also challenges in this area. We lack good infrastructure and logistics for it to be implemented. This can be done with the will from the government and the people also. It's not only from the government, like I said earlier. And also there's a complex supply chains in the country which needs to be worked on to see how we can get, especially in the waste area, how we can get waste for compost or biogas production. Or there are different uses also which we can use, especially also for food production. And also lack of information and customer awareness, that is also a challenge. Lack of technical skills, people need to be trained on some of these technologies. And then financial barriers, some of the technologies are a little bit high, but the government can come in also to try and kind of subsidize in this area. And lastly, and one of the biggest problem is enabling policies. Our government here is trying a lot in this area. They have the decadal plan, and we also have a master plan for agro-processing and also for other crops like sugarcane, which are being implemented. I'd like to thank you for your attention. Thank you.
Welcome to all stakeholders and colleagues attending this webinar today. I am Dr. Shahid Fazluddin, an RGM in the CSIR manufacturing cluster. I will be presenting an overview of the circular economy opportunities within the South African manufacturing sector. This talk was prepared with my colleague, Dr. Vincent Ujejo, who is an RGM in the chemicals cluster. In transitioning the South African manufacturing sector towards a circular economy paradigm, it is important to note the current state of the sector and challenges it faces. The sector has seen a decline over the last few decades, underpinned by deindustrialization, a trend similar to that observed in developed countries. It continues to operate on a linear economic model, burdened by excessive resource extraction, inefficiency, and waste. A heavy economic dependence on the extraction and export of primary metals and mineral ores with little beneficiation is a long-standing challenge. The export of unwrought base metals, such as PGMs, represent a major part of the national GDP and economic growth path. There is also a pressing need to address excessive greenhouse gas emissions to meet sustainable development goals, given our reliance on fossil fuels for energy supply. Global trends show that circular economy practice can help transform the sector into a more competitive, sustainable, and resilient one. Given its inherent resource intensity, the manufacturing sector has a lead role to play in this transformation, notwithstanding the new business opportunities this presents. An overview of potential opportunities is provided in the following slides, based on the 3 key circular economy principles listed below. By redesigning products and manufacturing processes and employing circular business models, significant resource efficiency gains can be made. For example, the National Cleaner Production Center, a DTIC-funded program hosted by the CSIR, has achieved notable energy and cost savings over a 10-year period under its Resource Efficiency and Cleaner Production Program, as indicated here. Chemical leasing is an established circular model in the EU, wherein clients only pay for functional units of chemicals used, reducing cost and waste. Reynolds' product as service model leases EV batteries and is preferred by over 90% of its customers. It extends battery life cycle by cascading to energy storage applications with effective management at end of life. The textiles industry is known for its resource intensity and dependence on hazardous process chemicals. Circular design encourages the use of natural fibers to avoid harmful chemicals, while innovative textile design targets the high levels of microfiber waste entering our ecosystems. Opportunities for plastics manufacturers lie in designing out this well-known waste problem based on the SA Plastics Pact target of 100% recyclable products by 2025. Sustainable reductions in virgin materials can be achieved by keeping products and materials at highest utility within the economy. Value retention processes, or VRPs, such as remanufacturing, refurbishment, or recycling, offer notable resource efficiency gains. Remanufacturing can save up to 80% of virgin materials use and 90% in manufactured costs. Caterpillar adopted remanufacturing decades ago, evolving its subsidiary Cat Reman into a profitable and competitive enterprise. Whilst recycling is an established industry in South Africa, there is a need to improve waste recovery rates. Low-hanging opportunities lie in the plastics industry. Reuse or cascading can alleviate the environmental burden from disposed clothing and textiles. Companies like the Clothing Bank in Rehoven are driving such initiatives within the local textiles industry. Manufacturers need to keep abreast of circular economy policy interventions as well. The Steel Master Plan calls for stringent localization and restrictions on steel scrap exports. Special economic zones dedicated to hydrogen fuel cell and auto catalyst manufacture offer opportunities for remanufacturing and refurbishment. The need for PGMs as a resource input allows for intrinsic beneficiation and the opportunity for recirculation of PGMs within the local economy. The National Waste Management Strategy recognizes the circular economy as having a key role to play towards the creation of a secondary resources industry based on waste. The call for extended producer responsibility schemes under the National Environmental and Waste Management Act may offer new business opportunities for manufacturers as well. Under its Industrial Symbiosis Program, the National Cleaner Production Center has achieved further significant landfill diversion gains, with notable cost savings over a 5-year period, as indicated here. The circumvention of non-renewable resources such as fossil fuels can help regenerate natural systems. The adoption of green technologies and scaling towards the green economy form a key part of circular economy implementation. National policy encourages the transition to renewable energy and materials, affording both financial and environmental gains for businesses. The Steel Industry Master Plan calls for greening of the local industry through increased use of solar, wind, and hydrogen for energy and process heat as a means to decouple from its fossil fuel dependence. Circular manufacturing of local solar and wind technologies may also be feasible, with similar prospects in the manufacturing of renewable bio-based fuels and materials. The deployment of digital technologies can act as an enabler for advanced tracking and monitoring of resources and waste across all industry sectors. 4IR processes such as additive manufacturing have disrupted traditional machining and casting methods, reducing product development costs and timelines. The ability for on-demand, digitally distributed manufacturing dramatically reduces physical inventories while building more resilient supply chains as well. In conclusion, the manufacturing sector is centrally placed to unlock circular economy opportunities by adopting circular design, value retention processes, and circular business models. Policy-driven changes can unlock new circular business opportunities, raising prospects for innovation in product design and manufacturing, whilst meeting sustainable development goals. Public, private, and RDI institutions have a mutually beneficial role to play in developing and implementing circular economy solutions within the sector. The application of circular economy thinking is not new to the sector. However, there is a need to scale existing CE initiatives within the sector, fund science, technology, and innovation opportunities that enable circular manufacturing, and explore new business opportunities and models. In closing, I would like to acknowledge Professor Linda Godfrey's support throughout this project. Thank you very much.
Good afternoon. I'm Anthony Cooper, and I'm going to present to you on unlocking circular economy opportunities for South Africa within human settlements. I would just like to acknowledge Tinus Kruger, who helped me put this together, Mark Napier, Linda Godfrey, and the rest of the circular economy team. So the problem statement for human settlements in South Africa is that 2/3 of South Africans live in urban areas. Often inappropriate spatial planning, so this is the legacy of apartheid and modernism in architecture. Sprawl and low densities and monofunctional neighborhoods. That picture then shows two of the consequences: traffic jams and a large swathe of grassland being built on with low density housing. There's also much informality and problems. Human settlements are energy and carbon intensive. There's inefficiencies and waste in how they function, and there are inadequate amenities, services, and public spaces and maintenance. So there is a need for sustainable, inclusive, and circular growth. We need compact, connected, and coordinated cities with higher densities, with mixed land use, and these cities need to be integrated with the transport. So there are three major aspects to the circular economy. The first is designing out waste and pollution. So one does need to consider the entire complex urban system. So this is providing services and infrastructure across multiple sectors. It is not just about buildings or building components or economic or production systems. It's the whole urban system. And one needs to maintain infrastructure to prevent the waste and to prevent inefficiencies. Now, it is not just a waste of resources like materials and food and energy and so on, but also a waste of space. And one key aspect for dealing with this is then in the sharing economy, that space gets reused for multiple purposes. Construction consumes vast amount of resources, and so one really needs to start at the beginning with the planning, designing, and then the monitoring of the manufacturing and building to try and design out the waste and the pollution. So there are a number of ways of doing this. One simple example is having standard sizes when specifying material, rather than complex designs with unique sizes of materials. One should also calculate the resource requirements accurately and share expensive equipment such as graders and cranes. And then what's very important is to recover unused materials from building sites and not just to throw them away. What can help is digital systems such as building information modeling. And then the materials can also be reused, such as concrete. And one should also aim to extend the lifetimes of the existing stock. So it's not just a matter of the new build, but also what is there. And this picture then shows an example of a Green Building Council of South Africa 6-star rated building. Then one should try to keep products and materials in use. So there are loops within the circular economy. So before the circular economy, it was a linear economy from where the resource came to where it just got disposed. But within the circular economy, there are loops where the resources move around within the economy and don't just get discarded. But these loops are dynamic, and these flows of resources, materials, parts, goods, byproducts, and so on are complicated because they bring together organizations with different cultures that are not used to working with one another. And then a key problem is that the costs and the benefits within the loop could be weighted differently against the different participants. So one might have to bear the extra costs so that others can get the extra benefits. And then there are significant time gaps between the costs and the related benefits. And this obviously applies particularly in the construction because there's a long time period for when whatever is being built will be used. And so it's about reuse, repair, repurpose, recycle, upcycle, renovate, reduce, dismantle, separate, remanufacture, share, lease. And some examples of keeping products in use is distributing expired but safe food to food banks and charities, though there can be legal problems with this, just-in-time procurement, so that you don't have the need for a large store of materials on site, having appropriate sizes of packages and portions of food, such as catering for single people so that they don't end up wasting food, reducing waste and the use of virgin resources, so trying to use existing resources, reverse logistics, where the manufacturer plans ahead to take back the packaging and the product once it's finished. And then things like food and garden waste have many applications, such as compost, mulch and fertilizer for growing algae, mushrooms and insects, for food and feed, for producing fibers, for bioenergy, for retrieving nutrients, for bioplastics and bioaromatics. And that picture then is an example of waste at a site that is not just put in a pile that people can trip over, but is separated and stored properly so that it makes it easier to be recycled or reused. So the third component is then regenerating the natural systems. So this is about the ecological restoration and regeneration. And it's important to realize that natural systems do occur within cities. It's about actively improving the natural environment, about feeding natural resources back, such as nutrients into the soil, and creating closed loop systems. So this picture, for example, is of what was the landfill that has now been restored and regenerated as a food garden. And of course, the natural systems provide ecosystem services, household waste, organic waste for livestock and poultry feed. They also reduce urban heat islands, they fix nitrogen and carbon, improve food security, and they provide jobs. So examples of this are urban agriculture, renewable energy, green roofs, green open spaces and settlements. And then to conclude, it's important to realize that there are many opportunities to make positive differences. Planning, design, and management at various scales are important. Entire city regions, municipal areas, cities, towns, neighborhoods, buildings. And then many of these concepts emerge from developing countries, but are they relevant for us here? We have our own unique challenges and local contexts, particularly poverty, unemployment, inequality, crime, and violence. We need reliable data and evidence. So the municipalities can improve their procurement policies, companies can reduce packaging, neighborhoods can share what they have, and households can adopt sustainable lifestyles. Thank you.
Good day. My name is Refilwe Mukwena. I'm a researcher within the Transport Infrastructure Engineering Impact Area within CSIR Smart Mobility Cluster, and I'll be presenting a briefing notes on the circular economy opportunities for mobility in South Africa. Before I begin, I would like to acknowledge Mr. Anton Steenkamp from the transport systems impact area, as well as Prof. Linda Godfrey, who's the principal scientist and the overall project lead for the CSIR Circular Economy project. Just a brief overview on the sector. Mobility is an important component of economic development that provides access between businesses and their respective markets, households, and communities. The business of mobility is a multidisciplinary field with a wide variety of stakeholders, and one definition by Rodrigue describes transport systems that can be conceptualized as the set of relationships between transport nodes, transport networks that cater to a specific transport demand. And all the components of a transport system are designed to facilitate the movement of passengers, of freight, and in some instances, information. And this can either be as separate or as joint components. Essentially, mobility is the movement of goods and of people. And in South Africa, this includes transport by road, by rail, maritime, and aviation, and is supported by an extensive transport infrastructure system within the country, consisting of about 750,000 kilometers of road network, approximately 30,000 kilometers of rail tracks, 8 commercial ports, and 11 principal airports, all of which support the movements of people and goods within the country through various transport systems, operations, and vehicles. The country, however, does have an extremely high reliance on road transportation in particular. Within the context of circular economy, there is a high focus on increasing the use of multimodal transport networks as a strategy to derive maximum benefits from each subsector while reducing pressure on road networks. Traditional linear approaches for managing mobility systems, operations, and infrastructure have been shown to be unsustainable as they lead to increased greenhouse gas emissions, where approximately 11% contribution to national greenhouse gas emissions come from transport, and a vast majority, over 90%, 95% of that is coming from road transportation. Another issue is depletion of finite resources for fuel and for things like constructing infrastructure. Traffic congestion, it leads to wasted time, decreased productivity, and also consequences such as urban heat island effects and resulting pollution from transport activities. And applying the principles of circular economy within the mobility sector provides an opportunity to get more out of the current systems through improved operational efficiencies. And the 3 principles I'll briefly touch on during today's presentation is firstly on designing out waste, secondly on keeping materials in use, and regenerating natural systems, where I'll give a brief example on each of these principles. So on designing out waste and pollution, resource efficiency in transport systems and infrastructure provides an immediate opportunity area for decoupling the sector from resource consumption, where business models such as mobility as a service, also known as MaaS, can be beneficial to transport users and operators. Globally, the mobility sector is seeing a shift away from an owner-focused value proposition to a customer-centered one, resulting in a move away from individually owned vehicles, be it for personal or business use. MaaS focuses on ride, car, or bike sharing, taxi or car lease and rentals, or a combination thereof. It's centered around the customer and provides various service offerings, including public transport needs, aviation, and maritime, as well as logistics and freight. Locally, ride-sharing platforms in South Africa show promising outlook with growing competition in the market, but we do lack the much needed and appropriate data sharing platforms to fully realize the benefits of this business model. Improving heavy vehicle productivity. One of the schemes that show great promise for supporting the circular economy is the Road Transport Management System, which aims to improve fleet management and sustainability while reducing logistic costs. The project has shown substantial savings, with 1 in 4 heavy vehicle trips being eliminated using the performance-based systems, standards rather. Fuel and emission savings of up to 20% can be seen, and road wear reduction of around 12%. These initiatives can be expanded within the country to form the foundation for self-regulation framework for fleet management in South Africa to support the circular economy within mobility. On keeping products and materials in use, vehicle manufacturing. This is essentially the process of manufacturing vehicles from end-of-life fleets, which would have otherwise been scrapped. Some international studies have shown that this can result in financial savings of between 30 and 50%, as well as double the fleet life of vehicles. In South Africa, there's opportunity in the taxi recapitalization program, which by 2015 had scrapped over 61,000 old taxis. And this was in efforts to improve taxi operations, which resulted in a total payment of 3.4 billion rand. With the incorporation of remanufactured vehicles, this figure could therefore be substantially reduced. Construction and demolition waste is currently mostly landfilled in the country, which is unfortunate considering the global shortage of sand. That's one of the most consumed natural resources in the world and a primary ingredient for construction of roads and other transport infrastructure. The Transport Infrastructure Engineering Impact Area has conducted a substantial amount of research on the use of recycled materials for road construction, where a wide variety of materials have been considered and investigated as a substitute for virgin materials. On regenerating natural systems, restorative and regenerative design is about restoring social and ecological systems to a healthy state and enabling these systems to evolve. Therefore, understanding current and future user needs and expected demands on mobility systems is therefore a critical component to regenerative and restorative design. The shift to alternative fuels and electric vehicles supported through renewable energy presents an opportunity to reduce greenhouse gas emissions. We've also seen a growing interest in using energy harvesting methods like solar roads, which essentially act as multi-purpose infrastructure that not only support transport needs, but energy needs using renewable energy. Another example of designing restorative systems includes increased use of strategies like the sustainable urban drainage systems that help reduce stormwater runoff during rains and floods. Even simple strategies like tree planting, particularly in urban areas along transport corridors, can assist in reducing impacts associated with urban heat islands. In conclusion, it's clear that the principles of a circular economy are not new to the South African mobility sector. However, while many of the underlying circular economy principles are already being applied in South Africa, more needs to be done to accelerate and scale up action to ensure a meaningful impact for all the industries within the sector and the country. Reliable data sharing networks and systemic design considerations for local conditions are needed for beneficial implementation. And applying circular economy principles requires a multidisciplinary approach with involvement from various stakeholders and participants through improved relationships across various sectors of the country. The benefits of transitioning to a circular economy are clear and include things like productivity, improving productivity and competitiveness with reduced cost of doing business, reduced congestion, and reduced greenhouse gas emissions. Thank you.
Good afternoon. My name is Xolile Msimanga, and I am a senior researcher in the energy industry team in the Energy Center. And I will be presenting on the energy component of unlocking the circular economy opportunities for South Africa today. With regards to the energy sector in South Africa, it is a resource-intensive sector which is characterized by high levels of inefficiency. Approximately 71% of energy consumption comes from the burning of coal. 20% of total primary energy entering the system is lost due to power generation processes, and 2% of South Africa's water is directed to energy generation. The sector is also highly linear, wasteful, and generates large quantities of gas, liquid, and solid waste. For example, fly ash and bottom ash from the electricity and petroleum sectors made up 75% of total hazardous waste in 2017 in the country. The energy sector is also the largest contributor to national greenhouse gas emissions. However, the energy is required in all economic sectors, and circular economy solutions in this sector will positively impact all the other sectors. South Africa is facing growing energy insecurity and has a high reliance on fossil fuels for energy supply. And the resulting waste provides the perfect impetus for transitioning to a circular energy system. To start off with, looking at designing out waste and pollution, things such as energy efficiency, reducing materials use in manufacturing energy technologies, and increasing energy technology lifespans are relevant for the energy sector circular economy path. Looking at the National Energy Efficiency Strategy of 2005, it set a reduction target in energy intensity of 12% by 2015 for South Africa. The target was achieved and exceeded, reaching 23.7% by 2012. In response to load shedding, several further energy efficiency initiatives have been implemented in the country. The Industrial Energy Efficiency Program, funded by GEF, assisted more than 450 industries to save 6.5 terawatt hours of energy, resulting in cumulative cost savings of 5.3 billion. Energy efficiency projects have also extended into the building industry. Example, new buildings have installations of solar panels, they use LED lighting, and they use highly thermal efficient building materials, which reduces energy demand. In the case of reducing wastage in the production and the manufacturing processes, in the wind industry, there is a potential to reduce waste in the production of permanent magnets, which contain rare earth elements. These magnets go into the direct drives in the generator. There is a potential to increase resource efficiency by narrowing the loops in the design and manufacturing processes of these magnets. An example is the Siemens Gamesa Renewable Energy, which has improved their material use and manufacturing related to permanent magnets. After sintering, permanent magnets are conventionally ground from rectangular geometries into the desired shape needed for installation in the generator. This is a wasteful process because the grinding residue cannot be recycled 100%. However, Siemens developed a new manufacturing method with their suppliers, which allows the magnets to be shaped correctly from the beginning. This eliminates the extra grinding step. This involves pressing the magnet powder into new shapes that match the final product and therefore avoids unnecessary waste. Moving on to the next component, keeping products and materials in use. Within the energy sector, this refers to things such as waste, gas, and heat valorization, carbon capture use and storage, energy recovery through waste to energy processes, repair, refurbishment, and recycling of energy technologies. Example, repurposing. So for waste to X conversion, examples that we looked at were eThekwini municipality's waste to electricity landfill gas project. Another example is the diversion of organic waste from landfills through composting and energy recovery through the production of biogas. The biorefining of various organic waste streams creates opportunities to recover high value resources The pulp and paper and sugar industries are already making use of this. Another example is using fly ash as a substitute for limestone and aluminosilicate in cement production, which is something that is being explored in the country currently, and something that is being done in other parts of the world. Example, Veolia in Poland. Waste heat recovery systems can also recycle the waste heat from processes back to produce electricity. Example, Anglo Platinum's 5 megawatt plant at its waterfall smelter complex in Rustenburg makes use of this. The next component looked at under this is the biomass, electricity and fuels. So in the UK, the Drax coal power station converted half of its units to run on biomass. By deploying bioenergy with carbon capture and storage, it will have minimal emissions to meet the UK's net zero climate target. Furthermore, biomass or captured unavoidable CO2 can also be used in as the carbon source in the production of synthetic liquid and gaseous fuels and chemicals. The next component is the repurposing of coal power plants or power plants. In 2020, Eskom announced that it planned to repurpose some of the decommissioned coal fire plants. They would do this through the use of renewable energy, battery storage, gas conversion, and agrivoltaics. This will already begin in 2022 with the closure of Komati Power Station. The next and the last part of this component is looking at carbon capture use and storage. The government has highlighted the importance of developing CCUS technology to minimize the impact from harmful CO2 emissions. The DMRE sees this technology as one of the avenues for continuing to take advantage of coal. In 2019, the government launched the Coal CO2-to-X program, which will focus on the production of green chemicals such as green ammonia and green hydrogen from flue gas. The last circular economy opportunity is looking at regenerating natural systems, which includes things like looking at renewable energy and green hydrogen. South Africa has come some way in their journey to increasing renewable energy in the country. Before 2011, the installed capacity in South Africa for renewable energy was less than 1%. However, it currently stands at approximately 10%. And with the new IRP determinations of 14.4 gigawatts for wind power and 6 gigawatts for solar power by 2030, this will increase to 33% by 2030. On a communal level, solar PV and wind mini-grids in unelectrified communities reduce the use of burning charcoal, wood, and other substances for cooking, heating, and lighting. It also has the potential to create jobs in those communities. The next component under this is green hydrogen and green transport. Undeniably, green hydrogen could play a pivotal role in a sector-coupled circular economy, offering a solution for decarbonizing a range of sectors, including transport, heating, chemicals, and iron and steel. Green hydrogen production is a major component of the government's strategy to decarbonize. Conversion of trucks to EV fuel cell technology will reduce the consumption of diesel significantly and establish further demand for hydrogen. Biofuels and synthetic green fuels can also be pursued. Example, sustainable aviation fuel for air transport. Lastly, oh, that was it, sorry. To conclude, the legacy of the energy sector in South Africa has gone against the principles of a circular economy. However, there are several ongoing efforts to reduce wastage and recycle waste for alternative energy use. Furthermore, energy efficiency has been prioritized to reduce energy consumption while reducing greenhouse gas emissions. The increased scale-up of current effort needs to move beyond a focus on renewable energy development and increase the scale in other interventions, such as green hydrogen. Undoubtedly, as South Africa embarks on the energy transition, the circular economy provides the opportunity for positive socioeconomic impacts. In 2021, at COP26, South Africa joined France, Germany, UK, US, and the EU in announcing a partnership to support a just transition to a low-carbon economy and a climate-resilient society in South Africa. It is no doubt that the energy sector has a long way to go in achieving circularity. However, the actions that have been taken by government and industry signal a need to achieve greater national resource security through resource utilization. And that is it for me today. Thank you.
To move straight into my presentation. As all of us recognize, water is the only natural resource needed for human socio-economic well-being, but critically, it is also essential for all life on our planet. So we've got to share what limited water resources we have on the planet with everything else that lives on the planet. Importantly, as you've heard from my colleagues already, water cross-cuts all of the economic sectors, some more than others. If one looks at South Africa, we're a water-scarce country, one of the 30th driest in the world, where the demand and competition for water is quite often very high. We receive less than half the world average annual rainfall of about 460 millimeters per annum. Coupled with this, we have some peculiarities in terms of our climatic regime in the country. Our climate is variable, characterized by cycles of wet or dry spells, but it's typical of the Southern African region, and droughts and floods are our natural hazards. So together with climate variability, we also have projected climate changes, which are regarded as key risk factors to our national water security, and particularly impacts on our national economy as well. And if one looks at water and water use in the country, we're currently using about 98% of our available water supply. It's expected that our demand will exceed supply by 17% by the year 2030. Now therein lies our problem. Left unchecked, this will definitely constrain South Africa's future economic growth. And traditional approaches to supplementing our water supplies are not as rosy as they have been in the past. If I take what I've said now and kind of use some graphics to illustrate the picture, on the top left-hand corner is our water balance, our national water balance, disaggregated into the 19 water management areas in relation to our water availability and our requirements in each of these areas, but at a national scale. And you can see nationally, our demands were about 13 billion cubic meters per annum, and we were slightly in the good to about 13.5 to 14 billion cubic meters per annum. So things were still okay. We had more water than we actually needed. But I think here's the bad news. This is the projection I mentioned earlier, that by 2030, our demands will exceed our availability, our supply, by at least about 2.7 billion cubic meters per annum. Now, if one looks at how the stratification of water uses in our country across the different economic sectors, agriculture uses the lion's share for about 2/3 of our water resources, around 61-62%. The second largest water use in the country is the municipal, domestic, industrial, some industrial and commercial uses of water at around 30%, and the rest of the economic sectors make up the smaller percentages that you see in this graphic. Interestingly enough, if one looks at the financial returns from this water use, agriculture, while it uses 2/3 of the water, only contributes about 2% to the financial returns from the water sales. Municipal sector, domestic, some industrial and commercial use of water now provides the bulk of the financial returns of around 60%. Right. Put this together, what are our possibilities and interventions in addressing this potential shortfall by 2030, but more importantly, immediately as we move into it. So let's look at the 3 circular economy principles and what are our prospects there in the water space. So principle 1, designing out waste and pollution. In the water sector, we're looking at reducing water use and wastewater generation. We're looking at improving water use efficiency and also having better water use practices, on-site practices. And this is essentially to offset this looming crisis and to close that gap between our water supply and demand. But I must state at this point that while we're talking circular economy now, the circular economy has been practiced in the water sector at least over the last 3 decades. It was not called a circular economy, but the principles and the practices are essentially what we are talking about here today, right? And one of these is that strong focus on what we call water conservation and demand management. Now, if one looks at this, this relates to plugging leakages, water losses, etc. And the assessments at that stage, where if one looked at implementing water conservation and demand management measures at municipal and industrial levels by reducing leakages, it had the potential to realize about 58 million cubic meters of water per year. More recently, results from the National Cleanup Production, the National Industrial Water Efficiency Program between 2015 and 2019 yielded close on to 900,000 cubic meters of industrial water savings across 80 businesses. Now imagine if we extended this to 200 businesses or 500 businesses, we could really scale it up to quite a substantial water saving. In the largest water use sector, the agricultural sector, the South African Irrigation Institute provides support to optimize irrigation practices, right? They kind of draw their membership across a range of designers, engineers, soil scientists, crop experts, etc. But their professed ultimate mission is the saving of water through technical interventions. They do a lot of training, etc. for the agricultural sector. One looks at the second circular economy principle of keeping products and materials in use. And here we're talking about the circular economy going beyond waste prevention and minimization. It is about the sustainable use of water, where maximum value is extracted from water resources while in use. And here we're talking about diversifying the water mix, using grey water, reusing water, treating wastewater, etc. And many people will recognize that the discharge of wastewater currently and historically has largely been seen as a burden and a cost. But that growing water scarcity in many parts of our country has resulted in a recognition of the importance of that wastewater collection, its treatment and reuse. Now we've got a number of examples dotted around the country. 2 that I just picked on for illustrative purposes here is mine water reuse at Imalasleni, where treated mine water is piped to a municipality supplying about 12% of the daily water needs, and any extra water is sent to other mine operations. Now this reuse prevents polluted mine water from impacting on the environment. It recovers additional water for municipal use and reduces the need for fresh water abstraction from rivers. Another part of the country, the dairy factory that has treated evaporated water, which is used for other applications within the facility, cooling, garden watering and cleaning. Now what this does is it eliminates the need for municipal water intake. So there's a savings on the water bill. And it's a reduction on the wastewater generation from the factory going to the municipal wastewater works. So it frees up capacity there as well. One looks at the third circular economy principle, regenerating natural systems. And here we talk about the traditional approach to water supply in the country has been supply oriented, and an investment, quite a substantial investment in engineered water infrastructure, building dams, building canals, etc. But there was also this early recognition that our water security risks cannot be managed only through this approach of engineered water infrastructure, and that the rehabilitation and regeneration of our natural systems, which both purify and supply our water, their inclusion in industrial processes, in treatment processes, and in societal development design are an integral part of the economy. Modular designs for new settlements in estates and homes, etc., become an important consideration here. Amongst the examples I've got, just 2 that we picked on. Working for Water, like I said, it's been around since 1995. And The benefits from the Working for Water, it's removing alien invasive plants in the country, has improved water security in some of the areas where they've had the WFW program working, enhancing stream flow, improving water quality, and supporting secondary industries where the trees that are felled, the alien invasives, are used for charcoal generation, for furniture, etc. A more recent initiative is the Ecological Infrastructure for Water Security Initiative, and this has a slightly different nuance to it, where it addresses transformative innovation in catchments governance. And this relates to nature-based solutions, almost like biomimicry as well, that addresses sustainable livelihoods and the well-being of people and water resources. So putting all this together, what does it mean for us in terms of water and the circular economy? So there's 4 strategic interventions we've come up with for now. And the first is looking at our biggest water user sector in the country, agriculture. And we said, let's start looking at decoupling agricultural production from water demand. And of 3 circular economy principles, all have a bearing here. And this includes primary agriculture, but also the associated downstream agricultural value chains, your agro-processing industries, etc. The second strategic intervention is decreasing wastage and increasing water use efficiency, particularly in the urban and industrial water use sectors. And here we're talking about plugging those leaks, tripping taps, etc. So reducing water losses, having more water-sensitive design, but importantly also the appropriate geographic location of critical and strategic industries, particularly water-intensive industries. Strategic intervention 3 is to increase on-site wastewater treatment and reuse that may even happen at a household level. And this is to minimize pollution impacts on the receiving environment and to extend water circularity. Last but not least of our strategic interventions is to strengthen public-private sector partnerships. And this is through various incentives and the greater inclusion of the private sector in innovation in circular economy interventions. Chair, I think I'll close off with just 2 points here. The one is that the circular economy is our no-option solution, and the second that wastewater is our new gold. And as a forward-focused intervention, the mainstreaming of a water circular economy paradigm in South Africa becomes critical. It provides opportunities to support and to fortify our current and future economy against projected changes and the means to build improved resilience to potential future shocks. These changes include climate changes, economic changes, whatever the case might be. With that, Chair, I thank you.
Wonderful. Thank you very much. And I hope that everybody can hear me live. Thank you very much to our CSR presenters this afternoon, and certainly for the very lively chat box that we've had on the side. And I wish that I could engage with all of you during the course of the presentations. But as indicated at the beginning, the intention for today was really around contextualizing what the circular economy means in each of these different sectors of the South African economy. Just in conclusion, in the last minute or 2 that we have, I think it's certainly clear, listening to the various presentations this afternoon, that all of these sectors are very resource intensive and they are also very carbon intensive. It's also clear that the circular economy is not new to these sectors. We have elements of circularity that have been practiced in some cases for decades, but haven't necessarily called it the circular economy. And so it's really a question of how do we scale up for impact and how do we unlock new opportunities. And in terms of my concluding thoughts for this afternoon, the first one for me, I think, is really critical. I think transitioning to a more circular South African economy is no longer an option. I think certainly my perspective of having engaged with the various experts across the different sectors is that there are high levels of resource inefficiency. There's resource security issues. We've seen it in energy. We see it in water. We certainly start to see it now from a materials perspective as well. So transitioning South Africa to a circular economy is certainly no longer a nice to have. Sustainable resource use is critical to South Africa's future development. And I think also looking at these 7 different sectors of the South African economy, for me, it started to highlight the big critical issues that really are facing South Africa, which we've never perhaps thought of in terms of a circular economy. It's things like improving the competitiveness of South Africa's manufacturing sector. It's about talking about greater food security from our agriculture and agro-processing sector, creating more sustainable, more livable cities. It's around developing efficient mobility systems to support business and communities. And it's really around energy, water, and materials security. The webinar this afternoon was, as we said, the launch of the CSIR project. It's around providing context of the circular economy in these sectors. And what we've done is we've taken a lot of information around the circular economy. We've packaged it into 8 short briefing notes. And today we've tried to package 8 short briefing notes into short 10-minute presentations. But these briefing notes are now available online, and we encourage you to download them to get a better sense of what our various presenters today have been talking about in terms of the circular economy opportunities in each of the sectors, but also as aligned with the 3 principles of the circular economy. And the URL, the website where you can download these briefing notes is circulareconomy.co.za/CSIR. In terms of the way forward, I mentioned to you that 3 of these projects will now go into more detailed studies in the coming 4 months to really start to look at these opportunities in more detail and to engage with their respective sectors in terms of better understanding the appropriateness of these opportunities for South Africa and their potential for implementation and for scale-up. As I indicated, the 3 studies that will be progressing is mining, agriculture, and manufacturing, which is led by Sumaya, Blessed, and Shahed. And I've included their email addresses because this afternoon we've had a wonderful response from our stakeholders. And so if you sit in one of these 3 particular sectors, I encourage you to engage with Sumaya, Blessed, and Shahed, and to make sure that you are then part of the future engagements that happen. We're planning to have stakeholder workshops as well. And of course, we'll be reaching out through the email list that we've established from today's webinar as well. And just to recap, I've included at the bottom again the URL where you can download the 8 briefing notes. So as the CSR, we're incredibly excited to take this research forward around the circular economy. As I mentioned, really focusing on it from a science, technology, and innovation lens, and trying to find and identify and unlock opportunities that can transition South Africa to a more circular economy, decoupling South Africa's development from resource consumption to be able to manage our development risks. So with that, I thank you very much for joining us this afternoon. You are also more than welcome to contact me if you have any particular queries. I know that we've been taking notes around the various comments that have been raised this afternoon, and of course, we'd love to engage with you as well in terms of the various issues that you have raised. So with that, thank you very much, and I wish you all a lovely evening. Thank you.
Thank you.